So the observations of 51 Peg B were confirmed, and there was indeed a gas giant orbiting 8 million kilometers from its parent star. That was a complete mystery, but it was just one strange anomaly. And yet the problem got worse because we can see this graphically as more extrasolar planets were discovered. The problem compounded. Okay? We have here a graph, and this graph shows the distance in astronomical units of a planet from its parent star. This shows the mass of the planet in Jupiter masses. Okay? So we're talking about gas giants here. So 5 Jupiter masses, 10 times the mass of Jupiter, and so on. If nebular theory, as we understood it at the time, and kinetic molecular theory were both correct, then this is what we should have seen as we collected more data on exoplanets and started to plot them on this graph. We should have seen very small planets composed of rock close to their sun, and then we should have seen gas giants ranging from the mass of Jupiter down to the mass of Neptune, far from their sun, from about 5 out to about 30, and maybe some variation on this. But this is the basic pattern that we would expect to see, because far from the sun is where the gases were moving slowly enough to accumulate. This is what was actually observed as we discovered more and more extrasolar planets. This is nothing like the prediction. What you actually have here is that we were discovering many gas giants, many of them much larger than Jupiter, a bunch that were 5 times the mass of Jupiter, 10 times the mass of Jupiter, a few of them 20 or more times than the mass of Jupiter, but all of them were close to their parent stars. These planets, these gas giants that were orbiting very close to their suns, came to be called hot Jupiters. And according to everything we understood about solar system formation up to that point, such hot Jupiters should not exist. And yet we found them in very large numbers. So what to do about this? Well, we'd already done step 1 in dealing with all this anomalous data. We checked the observations, and they were correct, and they were many. So the next step is to try to modify the theory to account for the new details. You ask yourself, we're not going to toss out nebular theory and start all over again to try to explain everything we thought we'd already explained. So the question is, well, is there a problem with kinetic molecular theory? Well, that's a theory that we've known for 200 years, and it's worked so well, we have no reason to doubt it. So the other possibility is that maybe there was some detail out there in the observational data that we hadn't considered. So we go to basic science. What would a planet have to do to move closer to its sun? Well, what it would have to do would be to slow its orbital velocity. The slower it moves, the more gravity can pull it in. That comes straight out of Newton's law of universal gravitation. So then we asked ourselves, or astronomers asked themselves, is there something that we can observe that we hadn't yet incorporated into our theory that could actually slow a planet down? Well, drag can slow a planet down. Drag is simply friction that comes from anything that's moving, passing through matter, whether it's air, whether it's water, but it runs into things, it loses energy, and that causes it to slow down. So now we went back to the empirical data that we had, and we asked ourselves, is there anything in the nebular theory, in the data we've collected about the solar system, that could actually produce drag on a planet? And at that moment, it became fairly obvious that yes, there is. because planets are forming in the protoplanetary disk, in the outer regions, forming from accreting gas and dust, but they're orbiting at the same time. And so as they orbit, they're constantly trying to plow through all of this nebular material. And the effect of that will be to produce drag on these planets and slow them down. And if they slow down according to the law of gravity, they will move closer to their parent star. And thus we got the idea of planetary migration, the hypothesis that was now added onto nebular theory as a part of the story is that gas giants do indeed form far out in their protoplanetary disks as predicted by kinetic molecular theory. When 51 Peg b first formed, it was far from 51 Pegasi. It was out beyond the frost line. But then the drag from all that gas and dust of the nebula slows these gas giants down, causing them to move into those closer orbits where we now observe these hot Jupiters. Now, does this explain anything? Because remember, the point of a hypothesis is to explain things. Well, let's take a look in the next video.